This completely normal sentence would carry a Claude watermark, but there is no hidden Unicode, no zero-bit character, no metadata attached to it, even no extra token. So if nothing has been added, where can an invisible watermark possibly? The answer is strange and much more interesting also. It hides in the choices that Claude makes while the sentence is being generated. Once you understand those choices, you will also understand why copying the text may preserve the signal, why code is harder to watermark, and why a positive detector result still cannot prove who wrote something. This is Anthropic's own explanation. The future Claude models will be generating the text that contains the watermark. Nothing is going to be added in the text. There are no hidden characters, and it doesn't require any extra tokens. Anthropic says that they are using the Google's DeepMind's version of the SynthID-Text paper. The watermarking changes the source of randomness when the possible words are getting chosen. In other words, Claude does not finish the sentence and stamp something afterwards, but the pattern is created while the response is being generated. Now, question is why now? Short answer is EU AI Act regulation. The Article 50 of the EU AI Act applies from 2nd August 2026, and it clearly mentions that provider must add the machine readable marks to enable the detection of the AI generated content. Now, Anthropic mentions this. They are globally launching the watermarking because they don't have the durable way to scope it by region. Now, this explains about the timing, but this does not explain the mechanism behind it. So here is the real question. If nothing is being added to the text, where is the watermark? It's inside the choices for the token. So to understand this concept very concretely, let us first understand the very basic need, how the LLM is choosing the next token. Now, LLM generates a text one token at a time. A token can be a word or a part of word or a punctuation or even a white space. The model reads everything generated so far, then it produces the raw scores called as logits for the next possible token. Let's take the example for this unfinished sentence. The deployment was surprisingly. The possible choices can be smooth, stable, or fast, clean, or safe as well. So there are several possible choices are present. The generation selects one token and appends it into the context and process again repeat. Now, the model is not always choosing between one possible token and the other or other not possible tokens. It often has a choices of many possible tokens. And that freedom is the space the generative watermark can use. Now, if you like opening the black box between you and the model, please subscribe to this channel. That is exactly what this channel measures and explains. Now, where the SynthID enters in the pipeline. In the normal generation, the model is generating the probability distributions for the next token, and the normal sampler is choosing from that distribution. Whereas in the SynthID style, the model still produces the same kind of distributions, but the sampler is now the watermark aware sampler. It has the secret key and the context of the recent token. Now, this pattern influences which token can be selected. No model is getting retrained or no file is kind of being changed in the formatting. Even no encoding related to the user or the organization. Now let's understand more in detail about watermark aware sampler. Let's think of it as a token tournament where the model is kind of producing the next token distribution. In our example, the deployment was surprisingly, then the model has kind of chose around 8 sample candidates. Smooth, stable, fast, clean, smooth, reliable, seamless, or fluid. Now, candidate may repeat itself. Nothing is suspicious yet. Every candidate is possible candidate. Now, let's introduce the hidden judging set. Till now, what we have the recent context about the sentence. That is, the deployment was surprisingly. We have the watermark aware secret key. These two produces one seed and that generates a scoring function. So candidate competes in a pair. Candidate with the preferred seed scores advances for the next round and the winners are paired again. After the final round, the token can be selected. In our example, the winner token is the smooth. So the keyed score decides which possible token can advance. But the smooth is not suspicious. Even the unwatermarked sampler could also select that. So every candidate entered from the model's own distributions first. So the important detail is not about the single winner. It's about hundreds of choices can be made. So for the next token, again the repeated tournaments can be made. So the watermark is distributed across the repeated key choices, not for a single token. Now, why the text can still look normal? Because the SynthID is designed to choose from the possible candidates, not from the random arbitrary nonsense. In our example, deployment was surprisingly, the possible candidates could be smooth, stable, clean, or safe. Anyone can be a good choice over here, but banana simply can't win over here just because of the secret key. Anthropic reports that no practical impact on the content or the creativity because of the watermarking. Even Google's SynthID also reports quality neutral output. But let's keep the boundary clear. The Anthropic is using the version of the Google SynthID, and no researchers has tested it from the Anthropic's private production configurations. So the key takeaway from here is signal stays subtle by operating within the reasonable choices. Now, the same mechanism tells us when the detections become strong and when it can fall apart. Now, one token cannot prove that Claude has written this. It's smooth. Even human can write this. Even the other AI model can also write this. So the detection only becomes useful when many eligible choices that lines up unusually and it creates single pattern. So the longer text gives more decisions, more freedom to the model, and it provides this stronger evidence that AI has been used or Claude has been used. But length is the only half of the story. Other half, how much genuine choice that has been existed at each decision. Now, we have reached to the important question. If someone flags your code or the content or the text that Claude has only proofread, what the detector can actually tell. Now, how the detection works. The detector does not scan for the hidden characters. It tokenizes the text and then using the corresponding watermarking key and the seed logic, it scores how consistently the pattern has been seen and then accumulates the evidence. The final score is then compared against the threshold, which is the threshold likely to be written with the Claude. So conceptually, what the detector is asking, are these token choices are unusually consistent with the pattern that has been produced by this key or not? Now, the published SynthID research says that the scoring works only with the tokenized text, watermarking key, and the scoring machinery. It does not need the underlying LLM. The result is very probabilistic, so there are no cryptographic signature that has been attached or no mathematical proof of authorship that has been added. So detection measures the statistical consistency with the keyed generation process in the simpler manner. How frequently pattern has been observed in the sentence and that pattern has been generated with key. Now, this distinction changes what the positive result is. Now, what a positive result means. Positive watermark signal simply can suggest that Claude was likely or partly involved in generating this text, but it cannot say who has generated this, which user has generated this, or which organization has generated this, or even all of the words are AI generated or not. Now, different providers can have the different keys or the entirely different watermarking methods. So the key takeaway over here is model involvement is not the author proof, but this token tournament can open the edge cases as well. Now, what are the possible edge cases? Let's say the text is very short. Thanks, looks good. Over here, there are only few tournaments that has been happened. So very weak accumulations of the evidence. Let's take about the second scenario of the code. Now, in the code, the correct code has not too many possible choices. So let's say if the code needs to be written like, okay, written user underscore ID. Over here, and choose written banana or written something wrong variable name because the correctness collapses over there. There are no possible choices more than one or two. So less freedom means less watermark opportunity here. Let's talk about the another scenario. Does copy pasting removes the watermarking or not? Definitely not, because the watermarking works based on the token that has been chosen. So if you simply copy paste, the signal travels. But if you edit it, let's say the light editing can remove some of the tokens or some of the words that has been chosen by the key. But if you do the heavy edit or the full rewrite, it may happen that the tokens, what has been chosen, that has been completely. So this explains the robustness limits. So let's not consider this as the watermark removal tutorial. The another scenario is, let's say, the proofreading. If you have written certain article or text and you are asking for the proofreading to the Claude, Claude changes couple of words. So very few Claude selected tokens comes in the proofreading. So the opportunity for the selection for the tokens, that is less over here. But let's talk about the translation type of scenario. So meaning has been constrained over that in the translation. So if I'm asking translate a text from English to Japanese, the meaning will be constrained. But now Claude is having more freedom to choose the target words, and many eligible token can be chosen. So the opportunity is more. So the Anthropic translations can carry the signal of the watermark. So the more flexible choices is that, the more available evidence will be there. So what can we actually verify now? Based on the Anthropic's announcements, the detector API is coming. So till now, with publicly, we can inspect the Anthropic's claims, the published SynthID method, and the Google's reference code implementations, and the technical consequences of that. That is related to the length or the code related scenarios or copy pasting or the editing related scenarios. Now, what independently we cannot verify or the inspect, what's the production key or the watermarking key that has been used, was the exact Claude production configurations or the detector actual implementations or the real threshold that is saying, okay, the Claude might be used in this or not. So this video is about the mechanism of the watermarking and the limits of it. This is not the fake detector demo. So in a nutshell, what we have seen so far for the Claude watermark, for a simple sentence, like the deployment was surprisingly smooth. There are no ordinary characters, nothing has been appended. Invisible histories, the repeated token choices that has been guided by the secret key. These are all the normal words, no unusual patterns, and there is a statistical detections API as well coming. So the watermark lives in how the words are chosen. This video helps you understand about the Claude watermarking. Please like and subscribe.